Howdy!
Hi,
Welcome
everybody.
back. 1.6?
1.6, the last lesson in chapter 1.
Everybody's favorite thing to do.
Word problems!
Word problems. Problems in context. Okay, so there we go. We're gonna write expressions, write equations, and all from a bunch of words. I think the biggest thing that they need to practice is making sure that they define a variable when they write things.
Yes.
Don't use X and Y or A or B or C or a happy face or a star unless you tell me what it means. In words, preferably. Unless it's already explained for you, which this one is. So what we're going to do is take just real quick, go through some of these. Number X decreased by 6 and then doubled.
And what we're doing here is we're writing an expression. So there's no equal sign that we need. We just need an algebraic expression for a number X decreased by 6, then doubled. So if we're going to decrease by 6, let's subtract.
We subtract 6 to decrease.
And then doubled.
And then we doubled. So we got to put a parentheses around it. And doubling means what?
Times by 2.
All right, that's easy. We're done. Okay.
We're done. X was already defined. It was a number.
All right, how about a salary after a 4.4% increase? Well, this is the one that people have trouble with when we do percentage of increasing and decreasing. So let me just write this. This means that the new salary is going to be 104.4% of the original. When you have a 4.4% increase, you are now 4.4% above what you had originally, which is always 100%. So
Right.
now you're at 104.4%.
Okay. So the original salary is already X dollars. They told us that. So there's our variable.
When you take a percentage of something, what are you supposed to do?
We multiply.
We just multiply, and we change the percent to a decimal
We do. So it would be
Move it over twice.
1.044.
times
the
x. And there's our expression.
And that's it. Next.
Nothing to it. Boom.
All right, word problem. The diameter of a right circular cylinder.
What's a
Mr.
right
Leckie?
circular
Oh
cylinder?
my goodness, it's a can of
It's
beans.
a can. It looks like that. Except for all the stuff's connected.
Yeah,
All right, so the diameter here is D. How's that?
it is great. And that diameter equals half of its height.
How about that?
That's awesome. Where's
Where
the
the
height?
height is right here.
It's beautiful. So obviously, sometimes with word problems, a picture is helpful, a diagram is helpful. I like to say, when in doubt, write it out.
That rhymes.
I know. That's
Okay.
why I say it. Okay, we're going to write the volume of the cylinder as a function of its height. So we've given you the volume formula. Volume equals pi r squared h. You're going to see problems like this on the ACT, on those standardized tests, and a lot of times they'll give you the function or the formula you need, but they won't give it with the right variables.
Okay, so right now we have a formula for volume in terms of, or as a function of,
Right.
the radius and the height.
We do.
What do I want to write the volume as a function of, though?
We want it as a function of only the height, so that r's got to go.
The r's got to go. So if we could solve for r
Okay?
somehow
And
in
replace
terms
it.
of h,
Oh, that would
we
be
could
good.
replace it.
Okay.
Would that work?
Yeah.
All right, but I don't have an r.
No, you have a diameter.
How is the diameter related to
Well,
the radius?
the diameter is 2 radii.
2 radii.
So in our little diameter equals 1/2 height, we would have 2 radii equal to half the height. Okay, so now we need to solve this for the radius so that we can then substitute it.
So I just have to divide by 2.
We do.
Well, what's 1/2 h divided by 2?
Well, half of a half is a quarter.
About 1/4 of h.
Okay? We're going to take that and we're going to substitute it into our volume expression.
Well, this is easy, but again, when we plug things into a function, we put what?
Oh yeah, we have to make a home for it. Remember the home?
And people think we're weird when we do this, but it solves so many issues. This is going to be pi
Times
times the
something.
radius squared times h.
And the radius is 1/4 h.
And the reason the parentheses are there, because we actually have to square not only the h, but also the,
1/4.
what's 1/4 squared?
1/16.
So this is volume equals pi times 1/16 times h squared times h.
But hey, Mr. Leckie, an h squared times an h is an h cubed.
Oh, right.
So pretty it up for us.
What's pi, which is over 1, times 1/16?
Pi over 16.
There we go.
And now it's much easier and pretty.
And that is volume written as a function of height. You could even go, you don't have to do this.
But we've been practicing function notation, so
There's
it's
the
not wrong.
function notation. The volume of the height is pi over 16 times height cubed.
Perfect.
Just
Next.
for that right circular cylinder. All right, now let's do some solving.
Okay. I like solving, so I'm going
You
to
like
jump
solving?
in. I do.
Before we can solve, we have to write some equations to solve, though.
We do. We have to write equations to solve, and then we have to solve the equations and obviously make sure that the answer answered what was asked. So you have to read the directions. Your
I
favorite
hate
part.
that part.
Okay. And again, we want to be defining our variables as we go. So if we read the first one here, one positive number is twice another positive number. Okay, so what do we have? We have a positive number. Pick a letter.
X.
Oh, he's kind of boring.
Boring.
So x is the first positive number. Okay? And it is, let's see, we have another positive number here, so let's pick y. Second positive number. Okay, once you get your variables, and there's usually two, let's go back and read it again. One positive number is twice another positive number. What does is mean?
Equals.
Okay, so x equals twice,
2 times.
2 times the other positive number y.
There you go.
Okay, second sentence, the sum of the two numbers is 390. So sum,
Sum means plus.
okay, so what are we going to plus?
X and Y, the two numbers.
All right, and it is 390. And now you're back to a simple system.
Systems. I remember those from Algebra 1.
Yep, that's more than one equation with the same variables.
So
Okay.
one of the ways to solve is by substitution.
It is. So instead of x, I'm going to replace this x and plug in what it equals. So make
2y.
a home for it. We're going to have a plus y equals 390, just like we do in our function notation. And we're going to plug in, me
2y.
and my colors,
Yes.
and then solve. 2y plus y is
3y.
equals 390.
And divide by 3, you get 130.
Okay.
So your second number is 130, which makes your first number 2 times that, according to one of our equations, which means the second number is 260.
The first number, but I know what you meant.
Whatever.
The nice part about defining your variables this way is you can simply go right back over here and write your answer, and it's already defined for you.
And if you're having trouble with the variables and what to do, answer the question. It says find the two numbers
If
in
it
the
only
problem.
wanted one of them, it would probably say find the first number, find the second number, find the larger number, something like that.
But tell us what they are.
Okay.
Alrighty, more percentage problems.
Joe Perlman, how
You
about
want me
it?
to do Joe Perlman here? All right.
So Joe Perlman is going to receive a pay decrease.
Oh, that sucks.
He didn't do his homework, and no, it's a recession. He's got a pay decrease.
Oh, well, there you
Okay.
have it.
His salary after the decrease was $27,095. So what was his salary before? So what's our variable going to be?
Well, there's our variable. That's
Look
the
at
answer
the
to our question.
question.
So
Yeah.
give me a letter.
I'm going to say, I don't want to say S because that looks like a 5. How about P for pay
P is his salary
before?
before the decrease.
When you
Now,
define your variables, be specific. Okay?
don't just say pay.
Yeah. Be
All right,
specific.
now I'm going to write kind of a sentence here because I know that the percentage thing,
Messes people up.
it does. All right,
It's
so
hard.
so let's
It's
try
confusing.
this. His new salary
Right.
is equal or is
Right.
a 3.5% decrease means he lost 3.5%.
He did lose 3.5%.
And he started at 100%, so that
He did.
means his new salary is 96.5% of his original
Yep.
salary. Now, this is not specifically mentioned or in so many words, but that's what this problem says.
Right. And if you can get it into that sentence, now you can get it into the letters in the equation.
Yeah, you don't have to write it down, but it helps. But if you're having a hard time with it, so his new salary
It's $27,985.
is given to us. Is means
Equals.
96.5% of something means we multiply the percentage times that salary.
So 0.965.
0.965
The
times
salary was P.
P, his
Is
original
pay.
salary.
Now we just have to solve. Divide.
Divide by 0.965.
I
and
did that
the
already.
Original salary turns out to be, was it
$9,000.
$29,000?
So he wasn't making that much anyway, and then he had to take a pay cut.
Poor guy.
Bummer.
Must be a teacher.
I bet he didn't do his homework.
But if they
Next.
didn't do their homework, they're not watching the video. So they don't even get the joke.
They take away my phone.
All right. Okay, let us
Jackie.
see. Another percentage
You want me to
problem.
do Jackie?
You can do whatever you
I'll
want.
get brave. It's percent.
All right.
All right. So Jackie's going to invest $25,000, part at 5.5% and part at the balance at 8.3 annual interest. How much is invested at each rate? Okay, so go to the question. How much is invested at each rate? This is our variables.
We need
okay?
2 of them.
We need 2 of them. So let's let X equal the amount of money she's going to invest at 5.5%.
That's a dollar sign, by the way.
I'll go 4 inches away from it and draw a line.
There you
It'll
go.
work.
The
Okay.
board is not behaving.
Y is the amount invested, amount of money invested at 8.3%. Okay? So part at 1% and part at the other. Okay. Now, let's go back and reread. She's going to invest $25,000.
So does that mean that X plus Y has to be 25,000?
Yeah, you can take a lump of money and put it here, and the rest of the money put it there, and those 2 lumps have to add up and be $25,000. Okay? So
Bunch
X
of
plus
lumps.
Y. Not them.
Oh.
They're not the lumps. There's lumps of money.
Got it.
Okay, the balance just means the rest of it. Okay, now, this is the interesting part, okay, and this is how this problem is different from the next problem. She receives a 1-year interest payment of $1,571. So remember, she was doing annual interest, so she's only got it in there for 1 year. But something has to equal $1,571. That's not $1,571.
Well, that's her total interest, right?
That is her total interest.
So it comes from two different accounts. So if
Okay.
we had the interest from the first account, and we added it to the interest from the second account, we should just get the total amount of interest.
Which is $1,571.
So all we gotta do is figure out how to find interest on the first and second accounts.
Okay, now this is a little bit different from Joe Perlman, because, and it's a little bit different from the very first problem we did, because we only want the interest.
Just the extra.
New extra money. So if I want 5.5% of the X amount, what am I gonna do?
You're just gonna multiply. You're gonna go 0.055 x, and that's just gonna be the interest. Interest is the percentage of your money that you put in for 1 year
Okay, so for the second one, we're gonna have 0.083
times y.
of the Y.
Okay, so at this point we have two equations.
Right.
So we have two variables. We can solve again by what method?
Substitution is
Substitution.
easier.
Okay. All right, you've got to be able to write these two equations. If you can't do that, it's going to be hard to show enough work to get some credit for these problems.
And then you're just kind of shooting in the dark. And there's a whole lot of numbers that add up to 25,000.
Yeah, there are. Okay, so
All right.
we could solve for x or y.
We could.
Since on our notes we solve for y, we're going to do that on the board.
Doesn't really matter.
25,000 minus x is y, and what we're going to do is substitute that now into the other equation with a y in it.
Okay.
I know there's decimals. I know there's 4 or 5 digit numbers, but just use your calculator. Just make sure you show your work.
So we're going to have 0.055x plus
0.083
0.083.
times y, which now is going to be replaced with 25,000 minus x. Notice there's a parentheses where the y used to be, and it all equals 1571.
Okay, so now we just do a little algebra.
So distribute the 0.083, and you're going to get 2,075 minus 0.083x equals 1571. Combine your like terms on the left side, you end up with negative 0.028x. And if you subtract the 2,075 at the
Okey-doke.
same time,
Fancy, fancy.
you'd end up with,
I lost my X. Hold on. Okay, what do I end up with?
you end up with negative
Okey-doke.
504.
Okay, and then we divide.
And we get x equals 18,000. Notice these are nice and pretty. They don't always work out so well. If it's money, round to 2 decimal places for money. Otherwise, go to 3.
If our
What does
totals-
x stand for?
Well, remember X was our amount of money invested at 5.5%. So we can just go back here and say that it's $18,000.
18,000 at 5.5%, and we only had 25,000 total, which means that we had 7,000 left. And if you're having a hard time figuring that out, you could go back and plug it in for y equals 25,000.
But again,
minus
if you
x.
set up your variables correctly and nicely and neatly where you can find them,
And
then
we can find
yes,